Very good. That is really dog and bugs. Genius.
Hey guys, welcome back to your next lesson in the probability topic. Here's our flashback question to start us off today. We have a 20-sided die, shown here, is rolled 100 times. How many times would you expect to see a multiple of 5? And how many times would you expect to see a prime number? So this is based off expected frequency from our last lesson. Pause the video, see if you can figure it out. Okay, so a multiple of 5, well, on a 20-sided die, that would be the 5, the 10, the 15, and the 20. So the probability that this happens would be a 4 out of 20. So now if we multiply 4 out of 20 with how many times we're rolling the die, which the question has said is 100, it'll give us how many times we expect to see a multiple of 5. Okay, so 4 out of 20, we've got the 5, 10, 15, 20, multiply with 100 gets us our expected frequency, which is 20. Okay, so a fifth of the time we're expecting a multiple of 5, and a fifth of 100 is 20. That's the logic. Okay, so for a prime number, if you need a quick recap on prime numbers, they are numbers that have only two factors. So you can only multiply itself and 1 to get that number as an answer. So for example, 3 is a prime number because you can only do 3 times 1. But 4 is not a prime number because you can do 4 times 1 and you can do 2 times 2. Okay, so our prime numbers from 1 to 20 are shown here. Okay, I know 1 feels like it should be prime because you can only do 1 times 1, but the definition of a prime number is they need to have two factors, 1 and itself. The number 1 only has one factor, so it's a bit of a weird one, but it's actually not considered a prime number. So we've got 2, 3, 5, 7, not 9 because 9 is 3 times 3. 11, 13, not 15, 17, and 19. Okay, so out of 20, that is 1, 2, 3, 4, 5, 6, 7, 8. So an 8 out of 20 chance. So we multiply our probability with our number of trials and we get 40 expected results. All right, cool. So today we are moving on and having a look at what is called multi-stage events. So this lesson and the next lesson in this topic is going to finish us off, and I would definitely say this is the more challenging part of probability and standard maths. I know, especially if you've not seen this before, these concepts can be pretty confusing at first, and they do take quite a bit of practice before you feel comfortable with calculating probabilities of multi-stage events. Okay, to start us off, we have a coin being flipped and then a standard 6-sided dice is rolled. So an example of an outcome of that multi-stage event, because there's more than one thing happening, we're looking at two things happening in total. So one outcome could be heads on the coin and 6 on the die. So that's one example. How many different examples are there? How many outcomes are there for this multi-stage experiment? So to answer that, the long way is you can list them, and a convenient way of doing that could be a table. So you've got heads and tails for your coin, 1 to 6 for your dice, and here are your 12 outcomes. So the answer is 12. Okay. The shortcut to getting to that answer is to say, well, the coin has 2 outcomes, the die has 6 outcomes, so in total there are 2 times 6, which is 12. Okay. So if you want to find out how many outcomes there are when there's multiple things happening, you really just multiply how many possibilities there are at each stage, and it gets you your total. Okay. So we're going to write down that for a multi-stage event with outcomes, and this is for an example, like a 3-stage event with number of outcomes A and then B and then C, the total number of outcomes is going to be A times B times C. Okay, so we're multiplying. An example of what I mean is, so we have a cafe, it's got 3 options for entree, it's got 5 options for the main course, and you've got 2 possible desserts. And we're thinking about how many possible different meals could you have at this cafe? So how many different ways could you order an entree, a main, and then a dessert? Okay, so we're going to use the logic that we have up here. We can think of this as like a 3-stage event or outcome, where the first stage has 3 options, the second stage has 5 outcomes, and the last has 2. So to find out how many possible outcomes there are in total, all that needs to be done is just 3 times 5 times 2, which gets us 30. So that means that at this particular cafe with these options, there are 30 different ways you could order entree, main, and dessert. So 30 different unique meals, I guess you could say. All right, let's take a look at another example. Here we have a license plate, like on the back of a car, being made with 3 letters and then 3 digits from 1 to 9. So an example is down here, UZM981, okay? How many possible different license plates are there? So using these categories, or this sort of way of doing it, how many different possible license plates could we have? So the way we're going to think about this is we're going to think of our license plate as a 6-step multi-stage event. Okay, so we're going to set it up like this. All we need to figure out is how many possibilities are there at each stage, and just like with the cafe example, we'll just multiply them all together, and then there's your answer. So if we're using a letter, how many options do we have? Well, there's 26 letters in the alphabet, so these first 3 are going to be 26s. And then for our digits, we've got from 1 to 9. We're not going to use 0 because zeros just look like O's, so it's confusing. So you don't typically see zeros, or they're just O's. So for our digits, we are going to have 9 options. Okay, so we're going to be looking like this. The 3 letters, 26 times 26 times 26, and then the 3 digits is the 9 times 9 times 9. Okay, putting that through the calculator, we get 12,812,904. All right, now for part B, if you were given a random license plate, so it was auto-generated to just have a random assortment of 3 letters and then 3 numbers, what is the probability that you get the same license plate that I have on my car? If you want to know which car to vandalize in the staff parking lot, Pi 314. Okay. So the way we're going to think about this is that, as we said in part A, there are 12,812,904 possible different license plates. Pi 314 is just one of those many, many, many options. So if you were given a random license plate, the chances that yours matches this perfectly are just 1 out of the 12.8 million chances. So that is our probability, okay? Total number of outcomes, and Pi 314 is just 1 of those outcomes. So there is your probability. All right, so looking at some more probabilities of multi-stage events. If we have 2 separate events, A and B, and those events are independent, and what I mean by independent events, I mean that if A occurs, it doesn't change the chances that B occur, okay? A simple example is, let's say A is, like before, flipping a coin, and B is rolling a dice. If I get heads on the coin, it's not going to affect the chances of me getting a 6 or a 5 or a whatever on a dice because the events are independent, okay? So if you have 2 events that are independent and you want to find the probability of the first event happening and then the second event happening, all you need to do is multiply them. All right, so this is referred to as the multiplicative law of probability. It basically just says if you want to do the probability of 2 events both occurring, you just do their probabilities multiplied, okay? So simple example, like I said, flipping heads on a coin and then rolling a 5 or 6 on a die. They're obviously independent events, so we'll just find their separate probabilities and we'll just multiply them. Okay, so heads on a coin, obviously 1 out of 2. A 5 or 6 on a die is 2 out of 6 options. So here is the probability they happen independently. The probability that we do both is going to be a half of 2/6, which is 2/12, which simplifies to 1/6. Okay, so 1/6 is the probability that we do both of these things because we are multiplying their individual probabilities. Okay, so this is a very, very important concept in this course. We're going to do lots of examples today and in the next lesson on how we use this to look at all sorts of different types of events. Here's our first one. So we have every time Johan throws a dart at a dartboard, there is a 2 in 7 chance that he actually hits the board. Okay, which means logically there must be a 5 in 7 chance he's going to miss. Okay, what is the probability he hits 3 darts in a row? So in this case, we have a 3-stage multi-stage event where we want to do hitting and then hitting and then hitting. Okay, using the law on the last slide, all we need to do is multiply the 3 probabilities together. Okay, here's the probability he hits on the first, second, and third. So the probability he does all 3 in a row is going to be these 3 multiplied. Okay, so we end up with 8 out of 243. Okay, there's an 8 in 243 chance he hits 3 in a row. Okay. All right, and for question B, we're finding the probability that he misses 6 times in a row. So as I said at the start, if there is a 2 in 7 chance that he's going to hit the board, logically there must be a 5 out of 7 chance that he's not going to hit the board, because those are the only two options. All right, so if there's a 5 in 7 chance he misses once, if you want to find that 6 times, you just need to multiply 6 times. Okay, miss, 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 miss. Multiplying those all together, and we get a fraction that my calculator can't display, so we'll just write a percentage as 13.28%. So your calculator might say 0.1328, etc. Okay, not super important. All right, and now for question C, we have if he throws 2 darts, what is the probability he misses one and hits the other? Okay, this is a really tricky question. We're going to be exploring more of these next lesson when we start looking at probability trees. But the trick with this question is, so yeah, we could just say that he misses one, which would be 5 out of 7, and then he hits the other, which is 2 out of 7, and then we could just multiply those. Okay, the problem with this though is that we could reverse that. We could have us hitting on the first throw and then missing on the other throw. So there's actually 2 ways that this can be done. Okay, we can go miss and then hit, or we can go hit and then miss. All right. So in probability, when you have 2 outcomes that both match what you're trying to find, what you need to do is add those 2 outcomes together. Okay, for example, if you're thinking of even numbers on a die, you've got a 1 in 6 chance of a 2, a 1 in 6 chance of a 4, and a 1 in 6 chance of a 6. So altogether, you've got 3 out of 6. Okay, similar logic here. This works, but this works as well. So we're going to include both of these by adding them together. Okay, so my typical rule that I use in probability that makes sense to me is that when I'm saying and, I multiply, and when I'm saying or, I plus, and it works most of the time, okay? So for this one, I'm doing miss and hit, or hit and miss, okay? It gets us our correct answer of 20 over 49, but if that's not making heaps of sense right now, stick with me because I'm going to be doing more of these in the next video, and hopefully you'll feel more confident. Okay, for our last example today, we have 2 standard regular dice are rolled. What is the probability that both dice show a number less than 6? Okay, so once again, we have a 2-stage chance experiment, and to find the probability of the whole thing, we're just going to multiply the 2 stages together. Okay, so if I rolled the first dice, what is the chances I get a number less than 6? Well, it could be 1, 2, 3, 4, or 5, so it's going to be 5 out of 6. Okay. The chances I do the same thing on the next dice are the same. That's also 5 out of 6. So if I want to do both of those, it's going to be 5 out of 6 times 5 out of 6. Okay, this and this, which works out to be 25 out of 36. Okay, now for the next one is a bit of a tricky question. We have at least one of the dice shows a 5. Okay, like I said, this is a pretty complicated question. I think the best way to think about this one is to just look at your options. Okay, if we just draw a really quick table of our dice roll, here's the first one, here's the second one, and here are our 36 options. Okay, this square here represents a 1 and a 2. This square over here represents a 4 and a 2, and so on. Okay, so looking at our 36 options, our 36 squares, how many of these have a 5 in one of them? Okay, so we've got the 5s on the first dice down here. We've got the 5s on the second dice across here. And then we've got this square here, which is both of them. So it's got 5 on both dice. So if we highlight both rows, this is all the 5s on the first die, all the 5s on the second die. So in total, we've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. There's your answer. There are 11 out of 36 possibilities where at least one of the dice has got a 5 and all the others do not. So a good motto for probability, especially with simple stuff like coins and dice, when in doubt, just draw up a table to look at all your outcomes, and it's sometimes easier to make sense of it, okay? So there is your answer, 11 out of 36. Okay, if that's making sense, you can get stuck into some practice questions, try and make more sense of this. For my class, that's in 5C on page 167, and here's your recommended questions. Okay, thanks so much for watching, and I'll see you in the next video. Cheers.